Alright, so we're going to start off today with a very simple warm-up, not stretching your brain too much to start off with. We're just going to go over some symbols. I love symbols because symbols mean that we're not having to write the word out. It's shorthand. So let's look at these symbols, and I even gave you a word bank so you could use your context clues and your prior knowledge. That first one, number 1, what does that symbol stand for? Very good. Parallel. Someone in my first period said that they thought before I gave them the word bank, they said absolute value bars. I was like, ooh, I didn't think about that. If there was some more space between there, those could totally be absolute value bars. Very good observation. All right, number 2. What's your answer to number 2? What does that symbol mean? It's like an equal sign, but it's got this like squiggly on top. Some people tell me it looks like toothpaste. Good. This is the symbol for congruent. So we use equal sign for numbers, but we use congruent symbol for things like objects and shapes and segments and things like that. So we save this symbol for more like objects, whereas the plain old equal sign is reserved for numbers, numerical. All right, number 3. What'd you get for number 3? That's a ray. Yep. Like a ray coming out from the sun. It has an end point, the sun, and then it goes forever in one direction. And that's a band. Anyways, we'll talk about that more today. A ray, one arrow. All right, and that last one, by process of elimination, has to be that nice long word, perpendicular. Perpendicular. So it's like an upside down capital T. Very good, straightforward, easy. You can put away that sheet of paper unless you took it in your notes, and we'll have a new warm-up tomorrow. Are copying down, making sure our vocab list matches these words. You should already have the vocab list, but you're just making sure you have the correct words in the spaces. So today's our first real lesson in geometry. We're going to start with the building blocks of geometry: point, line, and plane. These are called the undefined terms because they're really the terms that we build everything else on. So we call these terms undefined because these terms help us define all of the other terms. For example, a segment is a portion of a line. Well, if we didn't have the word line that already existed, we wouldn't be able to define what a segment is. So we call these the undefined terms because they're the ones that help us define everything else. They're like the jumping board, okay? So we've got point. I represent it by like a little raindrop on a leaf. That's just a location in space. We'll talk about that. We've got line. Line goes on forever and ever in 2 directions, kind of like railroad tracks, but they don't go on forever. And plane, a flat surface that goes on forever in all directions. We call these the undefined terms. This is Euclid. He's nicknamed the father of geometry, Euclid. And the geometry that we study is called Euclidean Geometry. Okay, so what I was saying, we study Euclidean geometry. There's other geometries out there. There's spherical geometry. There's something called taxicab geometry. But we are going to mainly focus on Euclidean geometry. If you want to learn in depth about those, go be a math major in college. All right. We are not going to play charades. Sorry, I did that in my class, but we won't have time here. Notation, what is that? So there's a column on your notes and it says notation. See that column? Notation is, I define it as it's mathematicians being lazy. Look at this sentence right here. Ray AB is perpendicular to segment CED at point E. That's a lot of words. That's a lot of characters, a lot of letters. Mathematicians get caught up in their theories and proving something. We can't be bothered with writing all these words out. I mean, that's way too much work, and that's not worth our time and our brain power. So I call mathematicians being lazy because we take this sentence that you would write in English class, nicely full subject, sentence, predicate, all of that, and we use notation. We use shorthand. We make it shorter so we can scribble it down and move on and get all of our thoughts on paper. So what a mathematician would do with this sentence is they would say, ray AB is perpendicular to segment CD at point E. All of those words can be summarized by this notation right here. It's called notation. It's like shorthand. It's like abbreviating. But you can't just abbreviate it any way you want. We all have to abbreviate it the same way. It has to be agreed upon. So that's what we're going to talk about now, the agreed upon notation, so we can be lazy and literally never write the word perpendicular ever again. Good? Good. Let's go over it. Let's go over the notation for every word on our vocab sheet. All right. So the first word is point. A point is a location. It actually has no dimension at all. Did you know that points are 0 dimensions? They're dimensionless. So there's 1D, 2D, 3D. A point is 0D. It's simply a location in space. It has no size. It has no thickness. It has no length. It's a location in space. Okay? So here's a picture of a point, like a diagram. That's not the notation. A point, the notation is it's named with a capital letter. So all you write in the notation column is a capital P. That's how you name a point. You don't have to write the word point. You just put a capital letter and you've now named a point. So go ahead and write a capital P where it says notation. I want to make sure you understand the difference between these two. This is a diagram. This is notation. So if I were to go back to this, let me draw a diagram of this situation. So I've got segment CD. I've got ray AB. Ray AB. It's perpendicular to segment CD at point E. So I want to be really clear. The blue, that's a diagram of that sentence. The maroon is the notation of the sentence. Do you see the difference? This is a diagram. This is called notation. Notation is like if you were writing a paragraph, that's what you'd write. You wouldn't draw a picture inside the paragraph, okay? So diagram versus notation. Picture versus sentence. Let's move on to line. A line is a series of points all connected in a straight path. How many points make up a line? The answer is infinite. An infinite number of points get lined up. Get it? Line up. So point, all in a row, forever and ever in 2 directions. And when you connect them, when you line them all up and you squeeze one more in and one more in and one more in, you create a line. A line is made up of an infinite number of points. Infinite. This one, 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 and then more and more and more, and I can squeeze more in, and I can keep going, and I can sit here for the rest of eternity. So a line is a series of points that extends in 2 directions. Right here it says both directions. I guess that means 2, but it extends in 2 directions. So here's the diagram of a line. That's the picture. Think of a diagram as a picture. And here's the notation. Like if I were writing a sentence, I would write the notation in my sentence. So the diagram is already drawn for you. There are 2 ways to notate a line. You can notate it with 2 capital letters with a line on top. All right, so there are 2 ways to name a line. Yep, they just wanted to make it super confusing for us. Nope, there's not one way, there's 2 ways. So you can name it by naming any 2 points on the line, or if the line has a little label, a lowercase italicized letter, you can name it with the lowercase italicized letter. So I can name this line AB, or I can name it line lowercase italicized L. But notice, when I did this, did I have to write the word line? No. But when I did this and named it with a lowercase italicized letter, I did have to write the word line before I put it. So really this way is longer. But sometimes you have a line and you don't know any points on that line yet. So you can't name it by its points. You have to name it by that little letter off to the side. L is not a point on the line. L is not a point. It's the name of the line. Okay, so let's talk about it. Okay, here's some notation being used. Look, this means is line AB the same as line CA? Let's take a minute to look at that. All right, so let's look at it. When we say line AB, it means go through A, go through B, and continue forever in both directions. When we say line CA, it means go through C, go through A, and continue forever in both directions. So is the red line, the maroon line, the same as the purple line? Are those the same lines? Some people in my first period said, well, no, because AB is shorter than CA. But can lines be shorter than each other? By definition, a line goes on forever. So you can't measure a line. A line doesn't have a length. So if this one goes on forever, and the other one goes on forever, well, by golly, they're the same line. Lines don't have length. I can't say, oh, these are the same length. Lines can't even be congruent to each other. So the answer to the problem was yes. They are the same line. They go through the same points, and they go forever in those same two directions. So C lies, point C lies on line AB. They're what's called collinear. We'll go over that later. So, yes, they're the same. Next word, plane. Here's a picture of a plane. That's a diagram. Now we're going to talk about how to name a plane. How many letters did we use to name a line? Dos, 2 letters, or a lowercase italicized one. Be careful. It's just a lowercase italicized one. So you need 2 points to name a line. You need 3 points to name a plane. So I could name this plane XYZ. Of course, it has 2 options as well. It has a capital italicized letter in the top corner. So if you write the word plane, oh, and I meant to, sorry, I don't like this. Don't do this. You don't have to write the word plane. You can just put XYZ. Just super glue those letters together. No commas, no periods. XYZ. Don't put the word plane in front of it. Or you could write out plane and then put a capital italicized R. As you do your homework, as we do examples, you're going to get more used to how you can name these things. So, 2 choices. 2 choices. 3 points in the plane or an italicized capital letter. Next word is segment. A segment is a portion of a line. You take a line that goes on forever and ever and ever, and you cut it off. Chop, chop. So you chop off the arrows, they're gone. It now has a beginning and an end. A line has no beginning or end, but a segment has end points. Portion of a line consisting of 2 points and all the points in between them. How many points lie between A and B? How many? Interesting. How many? Very good, most of you. In between A and B, there's this point, 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 blah, 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 blah. There are, believe it or not, because points have no size, remember? They have no thickness. You can't be like, oh, I can't squeeze anymore. They're taking up all the space. No, they don't even have thickness. And so there are an infinite number of points between A and B, which is really confusing because a line has an infinite number of points and a segment contains an infinite number of points. Are there different levels of infinity out there? Go Google that. Go ask a calculus teacher. So yeah, in calculus you'll talk about limits and different infinities and all of that. But there does exist an infinite number of points between A and B. Okay. Here's the diagram for segment and here's the notation for segment. capital letter with a segment on top. There's only one way. I love the ones that only have one way. Yes, it has two endpoints, but there are an infinite number of points between those endpoints. Yeah. Segment, pretty easy. Don't put arrows on it. Two capital letters, segment on top. All right. Next word is ray. Array, you start with a line again. It's still part of a line. See how a segment was part of a line and array is part of a line? But this time, you only make one cut. You only chop once. So you cut one of the arrows off. You've got this end point, and then the rest of the line keeps going in one direction. So a line goes in two directions. A ray goes in one direction. A plane goes in all directions. So 1, 2, all gets a little confusing. Here's a picture of a ray, and here's the notation for a ray. So let's talk about when you name a segment, the order of the letters doesn't matter. When you name a line, the order of the letters doesn't matter. When you name a plane, the order of the letters doesn't matter. When you name a ray, dun da da da, the order matters. Very good. Put a star, put it somewhere. This is the only time when the order of the letters matter. Why? Why does it matter with a ray and nothing else? Great answers. Because a ray has a direction. Because a ray, there's only one endpoint. Because a ray, the order of the letters changes the direction of the ray. So you know which way the arrow is going. Those are amazing answers. That is perfect. Which letter needs to go first? Which letter needs to go first? It's actually called an endpoint, which is weird because you're starting with it. I want you to start with the endpoint. You're like, start, end, I don't get it, whatever. It's called an endpoint. That's the name of it, and that's what you need to start with. Okay. Let's look at this picture. All right. We're going to name line M another way, and it's hard. You guys can't do notation when you're typing, but think of how you would write it down on paper. How else could we name line M? Like, you could name me different ways. I'm Miss Tanton. I'm Amanda. I'm Mommy at home. So I, as a person, can be named at least 3 ways. Good. This line can also be named 3 ways. We could call it line M. We could call it line JP. Or we could call it what you wear to bed, line PJ. Get it? So there are 3 ways to name that line. Question number 2. Name the point that lies both on line N and line K. Name the point that lies both on line N and line K. Good. Now this is very important. I'm going to be picky about this. You name a point with a capital letter, right? The only correct way to answer this is a single capital letter E. I will be picky about being capital. Thank you. Alrighty, number 3. Name the line that contains point J and point E. Nathaniel, we're not going to be picky about the little dot is a little off center. Okay, don't hold me to that because our diagrams are not always perfect. This one's a little bit different. This one's a little bit K level. Because you're like, wait a minute, there is no line through J and E. There is none. But you have to be careful in geometry, and this is what's really different from algebra, and people have trouble with this. They don't like when I say this. Just because something isn't drawn doesn't mean it doesn't exist. Just because something isn't drawn does not mean it doesn't exist. There does exist a line through points J and E. And that line's name is either EJ or JE. There's only 2 ways to name this one because we don't have a lowercase italicized letter that they gave us. They didn't give us one. If they gave us one, there'd be 3 ways. In this one, there's only 2 ways. Yes, order doesn't matter. So good. Be careful. Just because something isn't drawn doesn't mean it isn't there. Could I put a line through those points? Yes, I could. All right. Next word is opposite rays. There's no notation for opposite rays, so we're going to leave that blank. But I do want to name the opposite rays in this picture. This is not notation for opposite rays, but in this picture, the opposite rays are YZ and YX. But there's no symbol that means opposite rays. Opposite rays will always form a blank. Line. Very good. Opposite rays together with our powers combined, they form a line. Sorry. Got too excited there. All right. Let's answer some questions. Name a pair of opposite rays, please. Name them together in a row in your chat. Good answers. So I want to get rid of a misconception, okay? I want to make sure we understand. Opposite rays form a line. Opposite rays, we haven't gone over this word yet, but opposite rays are collinear. They're on the same line. So remember, opposite rays, they go in opposite directions. Is the word opposite and the word different, are those the same word? Oops, there we go. Some people use those interchangeably, but opposite and different are not the same word. So in my picture right here, ray BD and ray BE, those are going in different directions. Are they going in opposite directions? No. See the difference? These are not opposite rays. Going in different directions is not the same as going in opposite directions. Opposite rays need to form a line, and BE and BD do not form a line. So the only correct answer would have been ray BA and ray BC. All right? What about this answer? Is ray BC and ray CB, are those opposite rays? Take a look at the picture. So be careful, very good. Here's ray BC. You start at B, you go through C forever and ever and ever in one direction. CB. You start at C, you go through B forever and ever in one direction. Are those opposite rays? No. Are these the same rays? No. They're actually overlapping rays. They're nothing. They're not a vocab word at all. Okay. Next word. Collinear points. Collinear. So non-collinear. Points that are not on the same line. Someone draw a line through A, B, and C. Nope, you can't do it. Impossible. So since I could not draw a line through these, this is not a line, that's like a curve or a parabola. Since I could not draw a line, those points are non-collinear. The next word is coplanar. Coplanar, same plane. No notation for this either. So some points on the same plane would be C, I, and D. Those all lie on plane P. Since they're all on the same plane, they are coplanar. Yes, you keep it. Non-coplanar, the opposite of coplanar, points that are lines not in the same plane. So some points that would be non-coplanar would be those same points, C, I, D, and E. Those 4 points are non-coplanar. I could not, impossible, to put a flat surface through all 4 of those points at once. Okay. True or false? Points U, X, and W are coplanar. Well, since U, X, and W lie in the top of this prism, they are coplanar. Points Q, R, and W are coplanar. Q, R, and W. This one's a little bit tricky, so be careful here. Collinear means I could put a line through it. Coplanar means I could put a plane through it without bending the plane. So you have to kind of let your brain stretch a little and realize, oh my goodness, even though this plane is not one of the sides that form this prism, oh my goodness, I could shoot a plane diagonally through this prism. I could do that. I could shoot it diagonally. That's kind of cool looking. So actually, those points are coplanar. So I want you to remember, collinear means I could put a line through it. Coplanar means I could put a plane through it. Not that it's already drawn. It might not be drawn. But I could do it. Sometimes you can't put a plane through 3 or 4 points, rather. All right, just to get through this vocab, you've heard this word before, parallel lines. This is how you show someone that lines are parallel, and this is the notation for parallel. Lines in the same plane that do not intersect. This is a new word, skew. Skew lines. There's a picture for it. The only difference between parallel and skew, there's only one word of difference, and that's the word not. Parallel lines. Coplanar lines that do not intersect. Skew lines. Non-coplanar lines that do not intersect. Coplanar, non-coplanar. Look, I'm like karate chopping. Coplanar, non-coplanar. So the only difference is that parallel lines are in the same plane and skew lines are not in the same plane. See how this guy is in the plane that's pictured? And this guy is shooting through the plane. He's not in the same plane as A. He's in a different plane. So this is what parallel looks like. They're going in the same direction. And this is what skew looks like. They're going in different directions. Parallel lines will never meet, and skew lines will never meet. There is no notation for skew. I wish there was. We should make up our own notation. That would be fun. Congruent. You've heard this word before. Two segments are congruent if they have the same exact length. It looks like an equal sign with a squiggly on top. I'm going to move on. We're going to get into midpoint a lot in Unit 2. A midpoint is just what it sounds like, middle. It is a point that is in the exact middle of a segment. It divides the segment into two congruent segments. So AB is congruent to BC. There's also no notation for midpoint, so we're going to leave that empty. There isn't. I wish there was. Could make up one for that too. All right, the next word is bisector. If you wrote perpendicular, I want you to cross that out. The next word is bisector. Now, a midpoint has to be a point. It just has to. A bisector can be a line, array, or a segment that divides a segment into two congruent segments. There is a symbol for this. It's a lowercase b with a circle around it. That word means, or that symbol means bisects. So like I can say, I can say line CD bisects segment AB. That's me writing in math language. That's math language. So that says line CD bisects segment AB. So it's a lowercase b with a circle around it. That means bisect. Bye. The last word on your sheet has no diagram and it has no notation. You can't draw this at all. It's called space. And space is this weird thing that's really hard to grasp. It's just the set of all points that ever existed and ever will exist. It's the set of all, and I mean all, A-L-L, points. Bye. All right, I'm going to go over a few more things. If you take two capital letters and you leave them naked, they have no symbol above them, then it actually means something that you didn't really mean to say. It means something else. Right here, this means segment empty. If you leave it empty, That just means the distance from M to T. We're not really covering that yet, so do not leave it empty. You must use a symbol above your letters, okay? We're not really going into distance until next unit, so don't leave your letters naked. So look at this. This means the distance from A to B equals 2. That's good. This means segment AB equals 2. A segment can't equal 2. The length of the segment can be 2, but this object itself can't be 2. So you never use an equal sign with a symbol. Can use a congruent sign, okay? Look at this. The distance from A to B equals the distance from A to C. That's good. That's a number equaling a number. Over here, this is bad. A segment can't equal a segment. An object can't equal an object. It can be congruent, but it can't equal. Here's how it should have been written. Segment AB is congruent to segment AC. That's good. So you use congruent with objects, and you use equal sign with distance. I hope that makes sense. These are objects. These are numbers. Last thing of the day, we're going to be translators. We're going to translate math into English. I'm going quickly because the bell's about to ring. Number 1, that is line MT. Number 2, we left it naked. It's not a line, it's not a segment. It's the length of segment PC. Number 3, ray XY. Number 4, segment HV. Number 5, that's a point. One capital letter, point A. All right, let's go over here. If I use a lowercase italicized letter, I can't use that by itself. I have to put a word in front of it, but I didn't want to give it away. That's how you name a line. That's one of the ways. Look at number 7. That is a whole sentence. Line GH is parallel to line IJ. Number 8. Segment OK is congruent to segment RA. And number 9. Line ME is perpendicular to line YU. All right. That's it for today's lesson. I feel like a TV show or something. You need to study your vocabulary tonight because you have a vocab quiz tomorrow. You will not have to write the definition, but you will have to write the word and maybe the notation. I give you the definition, you write those things. So be studying your homework, or not your homework, your vocab. The homework is on the calendar, and that's good practice of what we talked about today.